Welcome to our channel. Myself is Gautam VM, studying in Sri Venkateshwara College of Engineering. 1VE 23 EC 030. Third semester, Bromo section. Network analysis. Subject code BEC 304. Today we are going to discuss about two-port Z parameter. Two-port network. Port. A pair of terminal through which a current may enter or leave a network known as port. Two terminal device or element such as resistor, capacitor, inductor results in one port network. The two port network is an electrical network with two separate ports for input and output. It has two terminal pair acting as the access points. The current entering one terminal of pairs leaves an other terminal in the pair. Example. Why we study two-port network? Such network is useful in communication, control systems, power systems in electronics. Knowing the parameter of two-port network enables us to treat it as block box embedded within large network. From network, we can observe that four variables that are I1, I2, V1, V2, which are two independent. The various terms related to voltage and current are called as parameters. Z parameter. Z parameter also called as impedance parameter and the unit is ohm. Impedance parameter is commonly used in synthesis of filters and also useful in designing and analysis of impedance and matching the network and power distribution networks. The two-port network may be voltage driven or current driven. Network driven by voltage source. The source is connected to linear networks. The two source. The two-port network driven by current source. Examples. Box is replaced with a Z parameter as shown in the below. Z11, Z22, Z12, Z12, I1, I2, V1, V2. The terminal voltage can be related to terminal current. V1 is equal to Z11 I1 plus Z12 I2 equation 1. V2 is equal to Z22 Y1 Z22 I2 equation 2. V1 V2 equal to Z11 Z12 Z21 Z22 into I1 I2 in matrix form. The Z parameter that we want to determine as Z11, Z12, Z21, Z22. The value of parameter can be evaluated by setting I1 is equal to 0. Input port open circuited. I2 equal to 0. Output port open circuited. Z11 equal to V1 by I1. I2 equal to 0. Z21 is equal to V2 by I1. I2 equal to 0. Z12 equal to V1 by I2 if I1 is equal to 0. Z22 is equal to V2 by I2. I1 equal to 0. Where Z11 is a open circuit input impedance. Z12 is a open circuit transfer impedance from port 1 to port 2. Z21 is a open circuit transfer impedance from port 2 to port 1. Z22 open circuit output impedance. Example. Z parameter of two-port T network as shown in below. It having current, voltage, just solution. Port 2 open circuited. Similarly shown that in figure Z11 is equal to V1 by I1. If I2 is equal to 0, then ZA plus ZC equal to Z11. Also similarly, Z21 is equal to V2 by I1. Then Z21 is equal to ZC. Port 1 is open circuited. If Z12 is equal to V1 by I2 to I1 is equal to 0. V2 by I2 into ZC by ZB plus ZC equal to ZB plus ZC into ZC by ZB plus ZC. Overall it is equal to Zc. Z2 equal to V2 by I2. If I1 is equal to 0, then Z22 is equal to ZB plus ZC. From this solution, Z11 is equal to ZA plus ZC, Z21 is equal to ZC, Z12 is equal to ZC, Z22 is equal to ZB plus ZC. Second example, find the Z parameter of the circuit below. It having a 120 resistance, 40 ohm, 240 ohm. Step 1. I2 is equal to 0. Open circuit port 2. From below circuit, V1 is equal to 120 IB. IB is equal to 280 by 400 I1. Equation 2. Substituting equation 1 in 2, we will get that Z11 is equal to V1 by I1. 84 ohm. 84 ohm. V2 is equal to 240 IA. IA is equal to 120 by 400 I1. Equation number 4. By substituting equation 3 and 4, we will get that Z21 is equal to 72 ohms. From above circuit, V2 is equal to 240 Ix. Ix is equal to 160 by 400 into I2. Equation 2. Then we will get that Z22 is equal to 96 ohms. If V1 is equal to 120 Iy is equal to 240 by 400 into I2. Z12 is equal to V1 by I2 equal to 72 ohm. In matrix form, overall Z11 is equal to 84, Z12 is equal to 72, Z21 is equal to 72, Z22 is equal to 96. Thank you for watching.